This is Lab 28 for Honors Chemistry, the heat of combustion of magnesium. In this lab, we're going to determine the enthalpy, the delta H, for the reaction when magnesium combusts. Now you've done this reaction before. You've taken magnesium in an earlier lab this year and you've heated it up. You burn it with oxygen, you get great white light produced, and this powdery residue looks like ash, MgO. And while that produces a great deal of light and heat, it's very exothermic. It would be kind of difficult to estimate how much heat is released in that reaction if you were to try to measure it directly when this MgO burns and it is created by the burning of magnesium. It's so very bright that it would be hard to keep track of that. So if we were to break this one reaction down into two simpler ones, which is what we're going to do in this lab. The first one is going to be the reaction between magnesium and hydrochloric acid. At your lab stations, you will find samples of magnesium turnings, you will find 3 molar hydrochloric acid, and you will find styrofoam cups. The thermometers we'll be using in this lab will be the vernier. So instead of glass thermometers, you'll be using the vernier inside of a styrofoam cup. I caution you that if you stir too vigorously with the vernier probe, you can punch it right through that styrofoam cup, and since you will have hydrochloric acid inside the cup, you will have quite a mess. So be careful with those probes that you don't punch them through the styrofoam cup. So in part A, you're going to take some magnesium that you measure out, and you're going to put it together with that hydrochloric acid, and you're going to let that react. And you've seen it do this before. In fact, we did it not long ago in a lab where we determined the molar volume of the hydrogen gas that was produced. At the time, we were interested in the hydrogen gas. Now, what we want to measure, not so much either of the products, but the change in temperature. So as you react the magnesium with the HCl, you'll have taken an initial temperature. So record the initial temperature to start, and then once the reaction is complete, you're going to record the maximum temperature so that you see how much the temperature changes as a result of that reaction. You record that data here for part A. In part B, you're going to do much the same reaction. I should say, before you move on to part B, you're going to dispose of the products of this reaction down the drain. You can dump them into the drain and rinse with a little bit of water, and then you can go ahead and reuse your styrofoam cup. In part B, you're going to start with hydrochloric acid once again. You're going to measure that out into your styrofoam cup, but this time instead of magnesium, you're going to add magnesium oxide, MgO. And again, you'll start with an initial temperature for the HCl. You'll combine the two of them, let them react, and then record the maximum temperature once they are done reacting. When they're done reacting, you're going to end up with a combination of, again, magnesium chloride, and this time, since this is a double replacement reaction, you can predict what that other product is. H combines with oxygen. Yes, you've got it, for H2O. Again, we're not so interested in the products. We don't care so much about the magnesium chloride or the water. We want the temperature difference, the starting and the final temperature. That's it. That's all you need to do for the reaction for part A and for part B. Both of the products, when you're done, get washed down the drain, rinse out the cups, and return the equipment from wherever you found it. Once you have finished your laboratory work, you can begin your calculations right here. Now, if you look at the first calculation, it says change in temperature. That's no problem. For part B, 1B, it says calculate the amount of heat evolved by the reaction and therefore absorbed by the solution. So how are we going to actually find out how much heat has escaped as a result of that reaction? Heat. Calculation of a value we once called Q. There's an equation we once used. Do you remember what it is? If you're thinking this one, Q equals mCp delta T, you're exactly right. How's that? For CP, specific heat, it wasn't just water we used in this reaction, it was hydrochloric acid, so please use this value. Yes, it's in calories per gram degree Celsius. For the mass of the solution refers to the amount of hydrochloric acid you had. If you used 50 milliliters of hydrochloric acid, if the density of HCl is 1.048 grams per milliliter, then you're going to need to multiply by that many grams per milliliter. So it's going to be slightly higher than 50 milliliters, your answer in grams of HCl. That is what you need to put into your equation. That, I should say, plus the additional grams of Mg, or in part B, you're going to be using the grams of MgO. Remember, what you had in that styrofoam cup totaled not only the HCl, but whatever you reacted it with. It was either magnesium in part A, or it was MgO in part B. So we need the total mass of whatever was in that styrofoam cup goes in here, times the specific heat. We'll just use hydrochloric acid for the most part. That was the majority of the mixture in the cup, and the delta T is the change in the temperature. So using that information, that will give you the answer to 1B. The moles of magnesium, or magnesium oxide, you can calculate using the GFM for magnesium or magnesium oxide, and the heat per mole. So this is where you're going to take the heat that you calculated in part B, and you're going to divide it by the number of moles of magnesium or magnesium oxide that you used. And that's how you're going to get that value. That's going to give you your delta H, your enthalpy change for each reaction. And those values are going to go here. Your answers need to be in kilocalories, careful, kilocalories per mole for both of them. Once you have that, you can go ahead and use Hess's law and add those equations together in whatever way you need to in order to obtain, include that water equation, in order to obtain the overall reaction that we were looking for. Magnesium and oxygen create magnesium oxide. Good luck!